where we derive the correlation between X and Y of two random variables. And also, we talked about the joint central moments. And from there, we found the second order central moments, which is the covariance. So today, we're gonna go over the joint characteristic functions, which is yet another tool to derive moments. The first moment, the second order moment, like we just did last lecture. And also we did the same thing for the single random variable X in chapter 3, if you remember, okay? So as you see here on the screen, the joint characteristic function of two random variables X and Y is given by this equation, which is the expected value of the exponential of j omega 1 x plus j omega 2 xy, j omega 2y. And obviously, we can find this by taking the integration, double integration of the joint PDF of x and y times the exponential of j omega y, j omega 1x plus j omega 2y. And of course, from equation 1, we can derive the marginal characteristic functions of x and y. So to find the marginal characteristic function of x, we can set omega 2 in here in this equation 1, omega 2 to 0, which means j omega 2 y will go away, okay, as shown in equation 2, right? And we'll end up with this this integration, and the inner integration inside here, the integration of the joint PDF from minus infinity to infinity, as we learned in chapter 4, this is equal to the marginal PDF for x, right? So after you replace this one with the marginal PDF of x and you do the integration, as we learned in chapter 3, this will give us what the marginal characteristic function of x. And you do the same thing to obtain the marginal characteristic function of y by setting omega 1 to 0. So that's how we find the characteristic function. So nothing new, really. I mean, we learned that in chapter 3. This is just dealing with two random variables, okay? And these marginal characteristic function, these are just the single characteristic functions for x and y. Now, how are we going to find the moments? Now we have we did derive the characteristic function. How are we going to find the moments from that? Well, similarly, like we did that in chapter 3, the only difference here, we will have to do n plus 1 order partial derivatives of the joint characteristic function. So if you have a joint characteristic function, and you want to find the joint moment, okay, moments by using this characteristic function. So you take the first derivative with respect to to omega 1, and then you take this second one with respect to omega 2. Okay, so if you have n is equal 1 and y and k is equal 1, then and obviously this one is going to be minus j to the power 2, which is going to be minus 1. So you do the derivative, the partial derivative with respect to omega 1 first, and then after that, the result, you do the derivation with respect to omega 2, and then set omega 1 and omega 2 to 0. So really, nothing new. Like I said before, in order for you to understand chapter 4, chapter 5, you would have to understand chapter 2 and chapter 3, because they are the same, very similar. The only difference is we are dealing with two random variables here instead of one. Okay, let's take just a simple example here. just to clarify what we just said. For example, if we are given this joint characteristic function, it's already given to us. No, we don't have to derive it. And obviously, in some cases, you may have to derive it. But in this case, it's already given to us, and we need to find the mean of x. So this joint characteristic function for x and y. So we need to find the mean of x and the mean of y. Okay. So how are we going to do that? You go back to this equation. So the mean of x is equal to m10. It means we're going to set omega 2. In this case, we're going to set omega 2 to ish to 0 to find the marginal characteristic function of x. That's what we're trying to do here. So in order for us to find the mean of x, you need to find the marginal characteristic function of x, and then if you need to find the marginal, if you need to find the mean of y, you need to find the marginal characteristic function of y, just like we just said here. So you do that. In this case here in equation 7, after you do this, obviously in 7 here, the marginal characteristic function, it's going to be this equation right here, equation 7, except that omega 2 is 0. So you will end up with, or actually, rather than doing that, all you have to do is just set k to 0, okay? And you can do the, you can do the derivation right away, okay? But, either way, you'll end up with the same results, okay? So you can do it by finding the marginal characteristic function and go back to, let's say, go back to this lecture 3, lecture 14 of chapter 3, and you use this equation, or you set k to 0, okay? We just set k to 0, and you do the partial derivative right away. And of course here, since this one is 0, so the end result for the derivation is going to be minus j minus 4 omega 1 times the joint characteristic function here. Okay. Of course, after you set omega 1 to equal to 0, omega 2 to 0, the mean is going to be equal to 0. Okay. So you can do it in 2 ways. The first one, you can find the marginal characteristic function, and you just go back to what we learned back in chapter 3, or you just set k to 0 in this case, okay, which is nk. N is going to be, in this case, 1, and k is equal 0, and you do the derivations right away. And the same thing for the mean. If you need to find the mean of y, you do the same thing as we did in chapter in equation 7 right here. Okay, and of course, after you set omega 1 and omega 2 to 0, you will end up with the mean is equal to 0 in this example. So far, the mean of y is equal 0, which is equal to also the mean of x. Now, if I need to find the correlation between x and y, which is referred to as rxy, okay, which is the second order expectation xy, so which is m11. So in this case, you go back here and you set n is equal to 1 and k is equal to 1, and you do the integration or double the partial integration. So you do it with respect to omega 1 first, and then with respect to omega 2, or vice versa. It will give you the same results. And after you do that, of course, in this case, it's already been done. Okay. So you take this one. So you do it once, do it twice, and this is the result. and then you set it to 0. Okay, this is the result, and then you set omega 1 equals 0, omega 2 is equal to 0, which means the correlation between x and y is equal to 0 again. Well, since x and y, the correlation is 0, and the means of x and y are zeros, then this function, equation 11, which is the covariance of x and y, is also equal to 0. Okay, which means in this case, x and y are uncorrelated or independent. Okay, because everything is 0 in here. So that's all we have for characteristic function. As far as the next topic on chapter 3 is talking about the joint moment generating function, or MGF. Again, it's very similar to the characteristic function as we learned in chapter 3. The only difference is V1 in here. We it's the same equation. If you go back this to the first page here, the same equation. Instead of j omega 1, we replace j omega 1 with V1 and j omega 2 with V2. Okay. Otherwise, everything is the same thing. Okay. So we just, there's no imaginary operator in the MGF. Okay. So we found the moment generator function, and this one for non-negative random variables, which means the integration is going to be from 0 to infinity. It's not going to be from minus 0 to infinity because it's not negative. Okay. And we do the same thing how we find, once we find the MGF, we just follow the same approach like we did on page 1 right here, equation 6, the same thing. And that's all I have for today. Do you guys have any questions about today's lecture? It's kind of short, but I don't want to go beyond this today. Inshallah, on Tuesday, we'll try to finish chapter 5. إن شاء الله إحنا بنكمل chapter 5 يوم الثلاثاء، فاحتمال كبير يكون الثلاثاء اللي بعده إن شاء الله. أهلين الله يعافيك. Okay, any other questions? طيب, if you don't have any questions, inshallah, we'll talk to you on Tuesday. مثل ما حكينا, we want to finish chapter 5 on Tuesday. وبعدها مثل ما حكيت لزميلكم قبل شوي انه الكويز الثاني او الكويز الثاني راح يكون, خلينا نحكي 1 week later. احنا بنقدر نعمله Sunday بس خليه 1 week later عشان يكون معك وقت تدرس chapter 4 and chapter 5. واحنا طبعا we'll continue with the remaining material. رايحين نبدا بchapter 6, ممكن ما نغطيهوش طبعا كله, وشوي هيك كم شغله من chapter 7 و 8, يعني maybe a couple of things, يعني مش رايحين نكمل كثير لانه ما ضلش وقت اصلا. Okay, وبكون the end of the semester. ف if you didn't have any questions, inshallah, I will see you. I will talk to you on Tuesday, inshallah. Okay, يعطيكم العافية.